Determine the sum to infinity of the following infinite series with the condition that the absolute value of x is less than 1. Okay, let us begin. So here in this particular infinite series, we're going to name this series as S infinity, meaning it's a sum up to infinite terms. So here we have 1, so squaring 1, that gives us 1 as the first term. The next term, that's 25x added to 81x squared plus 169x cubed. Now clearly this series is not a arithmetic series because there is no common difference here, and also it's not a geometric series because there is no common ratio here. However, what we can do, we can check whether if it is an Arithmetico-Geometric series or not. That's a third possibility, but that's also this is not an Arithmetico-Geometric series because if we consider only the constant terms 1, 25, 81 and so on, these terms are not in arithmetic progression. They're not in arithmetic progression. However, if we consider the variable terms, considering 1 as the first term, followed by x, x squared, x cubed, now these terms are in geometric progression. They are in geometric progression because it has a common ratio of x. So here, the common ratio r, so that's x. We can take any term and divide it by the previous term. So what we'll do, we'll take this common ratio x and we're going to multiply each terms of the series with x. So that means we have x s infinity. So that's going to give us, so we'll take the first term 1 and multiply it with x. So that gives us simply x added to 25x multiplied to x gives us 25x squared added to, so 81x squared times x gives us 81x cubed. And this keeps on continuing. Now what we'll do, we'll perform a subtraction here. So we have 1 minus x multiplied to s infinity. So that gives us 1 added to, now 25x minus x, that's 24x added to 81x squared minus 25x squared. So that's going to give us 56x squared. Then 169x cubed minus 81x cubed, that gives us 88x cubed. And we have the remaining terms. Now we need to check whether if it is an Arithmetico-Geometric series or not. This is also again not an Arithmetico-Geometric series because here if we consider the terms 1, 24, 56, 88 are not in arithmetic progression. However, if we consider 1x, x squared, x cubed, now these are again in geometric progression. So what we will do, again we will take the common ratio r, which is x in this case, and multiply each terms of, well, let's name it. This is number 1, the series number 2 we got after subtraction, series number 3. So what we'll do, we'll take this series 3, infinite series number 3, and we're going to multiply each terms with x. So that gives us x multiplied to 1 minus x times sum up to infinite terms. So 1 times x, that's simply x added to, so 24x times x, that gives us 24x squared added to 56x squared times x, that's 56x cubed. So again we perform the subtraction here. So that's going to give us 1 minus x times sum up to infinite terms minus x times 1 minus x times sum up to infinite terms. So this will be equals to 1 added to, so 24x minus x, that's 23x added to, so 56 minus 24, so that's going to be 32x squared added to, then we have 88x cubed minus 56x cubed, so that's going to give us 32x cubed. Now if we extend the terms, we will see that we are going to get the next term as 32x raised to the power of 4. Now here on the left hand side we will simplify this. So we have 1 minus x, and we'll take 1 minus x times sum up to infinite terms as the common factor. So this gets multiplied to 1 minus x. This will be equals to 1 plus 22, 3x. However, we'll see here from this third term onwards to the rest of the terms, this sum is an infinite geometric series. So this is an infinite geometric series. Now if it is an infinite geometric series, now we can easily define its first term. So that's 32x squared. The common ratio r, that's going to be, take any term and divide it with the previous term to give us x. And we know the sum up to infinite terms of any geometric series, that's given by a over 1 minus r. Now that means for our case, we're going to get a, which is 32x squared, divided by 1 minus the common ratio, which is x. On the left hand side, we have s infinity multiplied to 1 minus x whole squared added to 1 plus 23x plus 32x squared over 1 minus x. So what we'll do, we're going to divide each terms with 1 minus x whole square. So we get 1 over 1 minus x whole square. Added to 23x divided by 1 minus x whole square. Added to 32x squared divided by 1 minus x whole cubed. Now, we can finally combine them. That I'm leaving as an exercise for you to try out. It's a very simple algebra. We have 1 added to 22x added to 9x squared whole divided by 1 minus x whole cubed. Hence, this is going to be the sum to infinite terms of the given series.